Today we're going to talk about arc lengths. So let's look at this first problem with the large and the small gears. Consider the gears represented by circle O and circle E. Find the degree measure of arc AB and FG. So remember that these are central angles because we have the angle at the center and it is formed with the two radii. So 60 degrees here means that the arc measure degree would be also 60 degrees. So we're looking at this and this right here. So then the next question says, what is the ratio of the degree measured to the minor arc to the degree measure of the entire circle for both gears? So we are thinking about the arc divided by the circle. So that would be 60 degrees over 360, which gives us 1/6. So this is the arc to circle ratio. Knowing that the degree measure of the two arcs is the same, do the two intercepted arcs appear to be the same length? So in this case, no. AB arc appears to be larger. All right, so arc length. So arc length is a fraction of the circumference. So distance traveled on the circle it's not the same as arc measure, and it's determined by arc measure and circumference. So you determine arc length by multiplying a fraction that represents the portion of the circumference determined by the central angle and the circumference of the circle. So the formula for determining arc length S can be written as follows. So if we write the formula, arc length, which is S, equals x degrees over 360 times 2 pi r. So remember, again, this is your arc length. And this is the arc to circle ratio. And of course, x degrees is the arc measure. Or you could also set it up as part of the whole. So we have x degrees over 360 is equal to the arc length over the whole, which of course the whole circumference, remember, is 2 pi r. That's how we find the circumference of a circle. And so that's another way if that helps you remember the formula better. Either way, it's just, what did we do? We just multiply both sides by 2 pi r to solve for S. It's the only thing that's different. So let's go ahead and take a look at this next one. It says, if the length of the radius of the larger gear, circle O, is equal to 12 centimeters, find the length of the minor arc AB. So for this, we're saying that this arc length, so the radius is 12 centimeters. And this is 60 degrees here. We want to figure out what the length of that minor arc AB is equal to. So the arc length equals the 60 divided by, because we're using S equals x degrees over 360 times 2 pi r. So 60 divided by 360 times 2 pi times 12, because r is the radius. And so when we go ahead and do this, we know 60 over 360, we already said was 1/6 earlier. So 1/6 times, and 12 times 2 is 24. So times 24 pi. So that would give us 24 pi divided by 6, which is 4 pi centimeters. And so that would be one way to solve the problem. And again, you could also use the proportions set equals. So 60 over 360 equals s over 2 pi r, right, which is 2 times pi times r, which is 12. So that gives us 60 over 360 equals s over 24 pi. And then you could cross multiply to solve, or you could and solve for s, or just multiply both by 24 pi. It's the same thing. It gives you the same answer. So either way, whatever works for you, if you want to use the first one or the second one. Looking at the next one, it says, if the length, the radius of the small gear is equal to 8 centimeters, we want to find the length of the minor arc. It says EF. I think that was supposed to be FG, so we'll cross that off and write FG. So for this, then that would be S is equal to, same thing, 60 over 360 times 2 pi times r, which is now 8. So that gives us, again, 1/6 times 16 pi. So that gives us 16 pi over 6, which we can reduce that fraction into 8 pi over 3 centimeters. So we're going to leave our answer in terms of pi, and also if we can use the exact answer instead of a rounded decimal answer, we're going to also do that. So for the next examples, it says, find the requested information, leave your answer in exact form, and round the answer to the nearest hundredth. So we're going to also round to the nearest hundredth if applicable. So for the first one, we have 10 inches for the radius and 80 degrees for the central angle. So we want to find the arc length. So the arc length is equal to the 80 degrees divided by 360 times 2 times pi times r, which is 10. So that gives us s equals 2/9 times 10 times 2 gives us 20 pi. So s is equal to 40 pi over 9 inches. So that would be the exact measure. And if we want to find the answer rounded to the nearest hundredth, so we could type that in, 40 pi divided by 9 gives us 13.96. So that's about 13.96 inches. Looking at the next one, we're going to find the length of arc BCA. So B to C to A would be all the way here. Given that the length of CB is 32, so CB is, of course, the diameter. So that means that the radius would be half of that. So 32 divided by 2 is 16. And we know this is 45 degrees for angle APB. That means this is 45 degrees. So that rest of the circle, of course, to find would be 360 minus 45 degrees. So arc ACB or BCA, same thing, is equal to 360 degrees minus 45 degrees, which gives us 315 degrees. So that's what we're going to use in our formula. So the arc length is equal to 315 degrees divided by 360 times 2 pi r is 16. And so that gives us S arc length is equal to 7/8 times 16 times 2 is 32 pi. And so when we multiply that all out, we would get 28 pi millimeters. That would be our exact answer. So then to find the rounded answer, 20 pi in our calculator gives us 62.83. So that's about 62.83 millimeters. All right, so why don't you guys go ahead and pause the video and do 9 and 10 on your own. When you're done, we can unpause the video and check our work. All right, so let's go ahead and look at question 9. So question 9 says, given a circle with a radius of 27 inches and arc length of 12 pi inches, what is the measure of the arc? So we want to figure out the measure of arc AB, which is x degrees. So if we use the other formula, s over 2 pi r equals x over 360, might be a little bit easier to solve for x, since all we have to do then is multiply by 360. So we have, in this case, s, which is 12 pi, over 2 pi times r, which is 27, equals x over 360. So right away we can see that the pi's are going to cancel out. So this would give us 12 over 54 equals x over 360. And we can reduce that to 2/9 equals x over 360. So then we are just multiplying 2/9 by 360 to solve for x. So x is equal to 2/9 times 360, which ends up giving us x is equal to 80 degrees. So the measure of arc AB would be equal to 80 degrees. For the next one, it says, given the measure of the central angle AOB is 120 degrees and the length of the arc AB is 24 millimeters, what is the length of the diameter? So here we have circle. So this is 120 degrees. So we'll call this AOB. And the length of the arc is 24. So that's S equals 24 millimeters, 24 pi. And of course, we're given x equals 120 degrees. So we want to figure out what the radius is to find the diameter. So in this case, we can set up our equation. So we have s over 2 pi r equals x over 360. So we get, in this case, 24 pi over 2 pi r equals x over 360. And of course, we can see that the pi's are going to cancel out right here. And that leaves us with 24 over 2, which of course we can simplify into 12 over r equals x over 360. And we can, and I forgot to put in the x, which is 120 degrees. So 120 over 360 reduces into 1/3. And then you can cross multiply to solve. So we have 12 times 3 equals r times 1, so r, and 12 times 3 would give us 36. So r is equal to 36 millimeters. And of course, the diameter is twice that, so the diameter would be equal to 2 times 36, which gives us 72 millimeters for our solution. The next one says we want to find the length of arc AB. So we're trying to find the length of this arc. So we can see from here, we have this angle ACB, which is an inscribed angle. So angle C is inscribed. So remember, that's the angle equals the arc divided by 2. So that means that if this is 75 degrees, then that means that arc AB's measure of AB's arc would be equal to 150 degrees because the angle is 75. So we're solving 75 is equal to the arc divided by 2. So 2 times 75 is where we get the 150. And if we want the length of the arc, we're going to use our formula. S is equal to the measure of the arc angle, which is 150 divided by 360 times 2 pi, and our radius is 48 centimeters. And so when we simplify, we get 5/12 times 96 pi. And then when you multiply that, you get 40 pi centimeters for the arc length. Question 12 says, given the radius is 60 millimeters, we want to find the length of arc AB, which is here. So we have the exterior angle. So remember that the angle is equal to the big arc minus the little arc divided by 2. So in this case, the angle is 21 degrees equals 96 minus x divided by 2. So then in order to solve, multiply both sides by 2. So 2 times 21 gives us 42 equals 96 minus x. Subtract 96 and we get negative 54 is equal to x, negative x, and so x would be equal to 54 degrees. So the measure of arc AB is equal to 54 degrees. And we want to find then the arc length. So for the arc length, S is equal to 54 over 360 times 2 pi, and the radius was 60. So that gives us 3 over 20 times 120 pi. And then when you multiply that, you get 18 pi millimeters. All right, so the next one says, given that AB is equal to 16 meters and BC is equal to 12 and AC is equal to 20. Find the length of arc BC, which is right here. So we know that this is a diameter here, which means that this arc is 180 degrees. And of course, we also have the inscribed angle for that arc. So the angle equals the arc divided by 2. So that means this is 90-degree angle right here, which means this is a right triangle. So we also know that if this is the diameter 20, then that means the radius is equal to 10. So first, we want to find angle A using right triangle trig. Of course, it only works for a right triangle. So if we want to find A, which I'm going to use this as theta, we have the opposite. We can use the opposite and adjacent So we could use tangent, we could use sine, opposite over hypotenuse, or we could use cosine, which is the adjacent over hypotenuse. It doesn't really matter. So you can pick one. So I'm going to go ahead and just use cosine of theta is equal to 16 over 20 because the adjacent over the hypotenuse. So to solve for theta, the only way to take it out of a trig function is to use the inverse. So theta is equal to the cosine inverse of 16 over 20. So if you're doing this in your calculator, make sure your calculator is in degree mode first off. And then you go to second cosine to get the inverse. 16 divided by 20, which gives us 36 point, if we round 36.9 degrees. So to make this a little easier, let's go ahead and say theta is equal to 37 degrees. We'll round to the nearest degree. So then the second thing we want to do is find the measure of arc BC. So angle A, of course, is an inscribed angle because the vertex is on the circle. So again, remember that the angle equals the arc divided by 2. So 37 degrees is equal to the arc divided by 2. So that means that the arc, which we'll call x degrees, is equal to 37 times 2, which is 74 degrees. And then the last thing to do is to find the arc length. So S is equal to 74 divided by 360 times 2 pi, and R is 10. So then when we solve, we get 37 over 180 times 20 pi. So that gives us, when we multiply 37 times 20 divided by 180, which reduces into 37 pi over 9. So just if you need help, you can always plug it into your calculator without the pi. So if I were to plug this in, I could do 37 divided by 180 times, and we're multiplying by 20. I'm just showing you guys if you have a hard time with the fractions, times 20, and hit the math fraction key. Notice you get 37 over 9, then just put the pi in, so that way you have the exact answer. And of course, this would be meters. So that is our arc length. So next question says we want to find the perimeter of this figure below. So to find the perimeter, remember the perimeter means that you're going to add all the sides together. So we know this is 15 cm down here. This is a half of a circle, and we know that because this is 180 degrees, so we need to find the arc length. So S is equal to 180 divided by 360 times 2 pi, and since this is 30, then of course that means this would be 15 for our radius, so times 15. So S is equal to, if you multiplied all this out, you would get 15 pi. So that is what the arc length is here, 15 pi. So the perimeter would be equal to 15 plus 15 plus 30 plus 15 pi. So that is equal to 60 plus 15 pi. And if we were to plug that in to get a decimal, we have 60 plus 15 pi, which gives us 107.12. So that's about 107.12. And this is, of course, centimeters. If we wanted the exact answer, though, we could leave this as our solution. And the next one says we want to find the perimeter of the shaded region. So if this is 20 yards, then this is also 20 yards on this side. That's 8 yards, then that means that the radius would be 4. And again, this is half of the circle, so that means that if that's half the circle, we can solve to figure out what the arc length is for this portion. So that tells us that we get S equals 180 divided by 360, which of course is 1/2, times 2 pi times r, which is 4. So 1/2 times 2 is just 1, so 4 pi, that's 4 pi yards. So this would be 4 pi yards for the arc length. Same thing here. So the perimeter would be equal to 4 pi plus 4 pi plus 20 plus 20. So that gives us 40 plus 8 pi yards. So that would be the exact answer. And of course, we could also find the rounded answer. So that is it for our arc length formula and also looking at finding the perimeters.